Hello guys, and welcome back to Euclidean algorithm. This time I would like to show you how this algorithm works on a specific pair of integers. These integers could be any integers. I've chosen 484 and 140 just because I liked the other integers that appear in Euclidean algorithm. Let's begin. First of all, we divide a by b with a remainder. So 484 is equal, you know that dividing with remainder assumes no actual division, is equal to 140 times 3 plus 64. 64. Why 64? Well, 64 is less than 140. Then the second step assumes dividing 140 by 64. So we see that it can be fit 2 times here, plus, let me just think, 128, 12. 12. And 12 is less than 64. And you see that this element goes here, and this element goes here. The next step of Euclidean algorithm will be dividing 64 by 12, 12 times 5, and plus 4, and we still continue because the remainder is not 0. We'll continue until we reach 0 remainder. So one more step, at least one more step. We divide 12 by 4, and here it goes 0 remainder, which means that Euclidean algorithm stops at this line. And once again, notice that this element goes here and this element goes here. Well, that's it. This is the Euclidean algorithm for specific pair of integers. And in previous video, there was a part when we show that each of the remainders can be linearly represented via these two elements, a and b. Let's just do this in this specific case. Well, first, 64, we see that 64 is 484 minus 140 multiplied by 3. But it will be difficult for me to write these numbers. I'll just write a and b. So 64 is a minus 3b. And the second remainder, 12. Well, we see that 12 is equal to 140, which is b, minus 64 multiplied by 2. But 64 is already a minus 3b, so we multiply this expression by 2. And, well, I suppose we can simplify this. Let's just say that it is equal to, what does it, 7b, right? 7b minus a, and the following remainder, 4, is equal to 64, which is a minus 3b, minus, well, 12, which is, just checking, yeah, seems correct, which is 7b minus a, multiplied by 5, and this will be equal to, well, a and 5a will give us only 6a, but it seems to me that we need to have another amount. Let me just check this line once again. It will take several seconds. So b minus a minus 3b multiplied by 2. Oh, right. I've forgotten 2 over here. So 7b minus 2a. Always check your calculations, even if they seem correct to you. Finally, we gain 11a minus 3b over here and 35b over here, so minus 38b. And this is the linear representation of the last non-zero remainder. And as you will soon know, as you will soon learn, this last non-zero remainder is the greatest common divisor of two original numbers, and this is the linear representation of the greatest common divisor.